Howdy, PreCal. It is Ms. Kosh, and today we're going to look at arithmetic and geometric sequences. Okay, so a sequence is an ordered list of numbers or objects that follows a specific pattern or rule. So basically, it's just in our world, it becomes a list of numbers, okay? And they have a particular sequence. So we can look at this one, find the next three terms. So when I see this, I see 12, 15, 18, 21, 24. Hopefully you have recognized the pattern. We are adding 3 each time, and so then I get 27, 30, and 33. The next one, I see 52, 48, 44, 40, 36. Maybe, hopefully, you've recognized that the pattern is what? You're subtracting 4. So when I subtract 4 more, I get 32, I get 28, and I get 24. Okay, these two sequences where you are adding or subtracting the same amount each time, these are known as arithmetic. It looks like arithmetic, but we say arithmetic sequences. And so they have a common difference. And in the first one, we had a common difference of a positive 3. And in the second one, we had a common difference of negative 4. We were subtracting 4 each time. Okay, so with our sequences, what we tend to do is we tend to write it as some sort of letter with a subscript, okay? And I'm not grading your handwriting, but I'm grading your handwriting. A sub n is not the same as a n, which is not the same as a to the n, okay? So I really do need to see that you have written it with the proper notation, okay? We can get rid of that for the actual notes. So what we have is the first term in our sequence would be known as a sub 1, and the second term a sub 2. And so we say this would be a sub 5, and that sort of thing. So when I list them out, I put a ton of them on the paper on purpose. We've got a sub 1. I went all the way out to a sub 10 so that you could see something in just a minute. We get to some random term, and that's the nth term of our sequence. It becomes like our general form, which we'll talk about in a minute. But the term that came right before it, well, okay, let's try this. What term comes right before the 10th term? Well, the 9th term. What term comes right before the 8th term? Well, 1 minus 8 is the 7th term. So what comes right before the nth term? That's the a sub n minus 1. It's the n minus 1th term. I think that's kind of fun to say. And so this is not the same thing. Be careful. A sub n minus 1 is not the same thing as a sub n minus 1. This is saying take the nth term, whatever it is, and subtract 1. This is saying take the term before the nth term. They are not the same. What would come immediately after the nth term? A sub n plus 1. So you've got a sub n minus 1, then a sub n, then a sub n plus 1. Okay, so let's look at this a tiny bit. If I'm at the first term, and I want the fifth term, then what I have to do, if I'm at the first term, and I want to get to the fifth term, I have to add my common difference 1, 2, 3, 4 times. And so my fifth term is equal to my first term plus the common difference times 4. So, okay, the next one, let's switch colors. If I'm at the first term and I want to get to the 8th term, then I have to add my common difference 1, 2, 3, 4, 5, 6, 7 times. Okay, so that is a 7. If I'm at now we're changing this up a little bit. If I'm at the 4th term, so here I'm at the 4th term, and I want to get to the 7th term, I have to add my common difference 1, 2, 3 times. Does this pattern seem to make sense? I hope you can't really answer me, but I hope that does. The next one, hopefully you notice that if I'm at the 3rd term and I want to get to the 10th term, I have to add it 1, 2, 3, 4, 5, 6, 7 times that I have to add that common difference. Well, what do you notice about these numbers here that we're working with? What do you notice about 5 and 1? Hopefully you notice 5 minus 1 is equal to 4. Hopefully you notice 8 minus 1 is 7, 7 minus 4 is 3, 10 minus 3 is 7. Okay, and so what that lets us do is if I want to get to the nth term and I'm at the first term, so say I'm at the first term, I have to add my common difference n minus 1 times. Okay, and now let's say I want the nth term, and let's let n be bigger than k, and I'm at the kth term. So this is saying I'm at any random term anywhere in my sequence. If I want to get from there to the nth term, I have to add my common difference n minus k times. Okay, and this actually becomes these two actually become formulas that we can use for arithmetic sequences. Okay, so now we're going to talk, we have 2 types of formulas, and one of them is called a recursive formula. And in a recursive formula, we have to state where to start, and what to do. If you don't have both of these, if I just tell you add 3, you're like, great, Miss Kosh, add 3 to what? I have no idea where to start. If I say start at 4, you're like, super. Now what? If I say start at 6, 7, that's not enough information. So I have to tell you where to start and what to do. And so what we do is we write that when it's arithmetic, it ends up looking something like this. They tell me where to start. The first term is 6. And then they're telling me your nth term, some random term in your sequence, if you go to the term right before it, remember how we looked at our little list right here? The term that came right before the nth term is the n minus 1th term. Then we're going to come to the term right before the nth term and add 2. So our first term is 6. Then to get to the next one, we're going to add 2. To get to the next one, we're going to add 2. To get to the next one, we're going to add 2. And I think it said write the first 4 terms, and we just did. Okay, this is called a recursive formula. And here is another recursive formula. You know what? Let me, I'll write another one. Okay, so on this one, our first term is negative 11. And now what they're saying is subtract 5. So subtract 5, subtract 5, subtract 5, and I have the first 4 terms. Okay? These other two, so this was also a recursive formula. So notice it tells me where to start, and it tells me what to do. I like to see these little brackets. If you're not good at drawing them, practice. I don't really care how you draw them, but we need to group these together because both of those things are required for that sequence. The other one would be, this is what we call an explicit formula. And the advantage of an explicit formula is it helps us find some random term. It's not quite as obvious. We can't generate the terms quite as quickly as we could here. But we can say, well, our first term, b sub 1, is going to be negative 7 times 1 plus 2, which is equal to negative 5. And our second term is going to be negative 7. We plug in a 2 for n plus 2. So I see a negative 14 plus 2 is a negative 12. My third term follows the same pattern. Okay, so negative 21 plus 2 is negative 19. And you may notice I'm subtracting 7 each time. So when I subtract 7 more, I'm at negative 26. So let's just make sure that we were right. So this is negative 7 times 4 plus 2. Negative 7 times 4 is negative 28 plus 2 is negative 26. Okay, and then this last one, so this one, we're going to start u sub 1 would be 31 plus 26 times 1. Well, these are silly numbers. I see 57. Yep, and I wrote a 7. 57. And then what I'm going to do, this next one, is I'm going to add 26 to that. 26, so I can think of, okay, this is 52 plus 31. 52 plus 31 is 83. And that's also going from here to here. I added 26. Okay, so let's do add 26. That puts me at 109. Add 26. So this was u sub 3, and this is u sub 4, and I'm too lazy to plug in. Add 26. What would be at 135? And so there are the first 4 terms of that one. Super. Okay, now I'm giving you 2 terms, and I want you to find the nth term. So this one, I'm telling you the 5th term and the 11th term. So we're going to use this formula, a sub n is equal to a sub k plus n minus k times d. And we're going to say, well, if I want the 11th term, but I'm at the 5th term, I'm going to have to add my common difference, 11 minus 5 times. Okay, so plugging in what we know that a sub 11 is equal to 35. We know a sub 5 is equal to 11. 11 minus 5 is 6. And we don't know the common difference, but that's what we need. That's one of the things that we need to find. So we will subtract 11. We will divide by 6. And we have found our common difference to be 4. So now I can take, it says given 2 terms, find the nth term. We haven't done that yet, but we have found the common difference, which is important and something we need. And so we can say, okay, a sub n would be equal to a sub k plus n minus k times d. Well, what do I know? I know both the 5th term and the 11th term. Let's work with smaller numbers. So we'll say a sub n is equal to a sub 5 plus n minus 5 times d. Now let's plug in everything we know. A sub n, we don't know that, we're trying to come up with the formula, is equal to 11 plus n minus 5 times our common difference is 4. And so technically I have written the equation. It's a little messy. We could probably clean this up a little bit. I see a 4n minus 20 plus 11. And so ultimately this becomes a sub n is equal to 4n minus 9. And let me kind of move that up a tiny bit. And so that is that's our final answer. Okay, the next one behaves in a similar way. I'm going to go a tiny bit faster and switch colors. U sub 13 is equal to U sub 7 plus 13 minus 7 is 6d. And so I have a negative 3 is equal to 27 plus 6d. Subtract 27, get negative 30 is equal to 6d. Therefore, d equals negative 5. Now I can say u sub n is equal to u sub 7 plus n minus 7 times d. Oh, hang on. I'll just put d. But on this one, you better put the d in parentheses because u sub 7 was 27 plus n minus 7 times. If I don't put the negative 5 in parentheses, it looks like I'm subtracting 5 from my answer, and that's not what I'm doing. Okay, so u sub n equals a negative 5n and a positive 35 and a positive 27. When I add those together, I see a negative 5n, 55 plus, so 62. And there's my formula. There is my nth term, and it's kind of the formula to the sequence. Okay, the next one, I'm giving you some terms, and I want to find the nth term. So this is a space for the nth term goes here, and then this will be the space for the 100th term. Okay, and then we'll write a recursive formula somewhere else. So what do I notice? Well, I notice I am adding 3 each time. So if I add 3 again, I'm at 26, I'm at 29. And then, so recursive formula, tell me where to start. We'll call this A. A sub 1 is equal to, we started at 14. And what did I do? Well, to get my nth term, I go to the term right before it, and I add 3. And so there's the recursive formula. My nth term, I can say A sub n is equal to A sub 1 plus n minus 1 times d. Well, I know my first term was 14. And my common difference was 3. So now let's clean this up a little bit. And I find A sub n is equal to 3n minus 3 plus 14 plus 11. And so my nth term is 3n plus 11. Now to find the 100th term, I could come back here and go plus 3, plus 3, plus 3, and count till I get to 100. But I have better things to do with my life, and hopefully you do too. But what I can do is I can come in here and say, okay, A sub 100 would be equal to 3 times 100 plus 11. That's 300 plus 11 is 311. And there's the first one, and I encroached on the space of other things, so let's make that a little bit smaller. Okay, the next one, well, let's see. My video might be getting long. Let me do, the next one is subtracting. I mean, maybe I'll come back and work, well, no, I'm going to skip it for now. Just for the sake of time, let's keep going. So on this one, okay, now they're saying identify the value of n. So they're saying we've got some random term in our sequence. Its value, the value of that term is 101. We want to know what term it is in the sequence. So let's see. We know we have the formula A sub n is equal to A sub 1 was the term we know plus n minus 1 times d. And now let's plug in what we know. We know A sub n is 101. We know A sub 1 is 20.5. We don't know n. We do know d is 3.5. Okay, so I have 101 equals, this becomes 20.5 minus 0.5 is going to be 20, minus 3 is 17, so this becomes 17 plus 3.5n. Now I subtract 17. What is that? 101 minus 17 minus 7 is going to be 94, 84 then. 10 more than that is equal to 3.5n. Oh, I have Desmos. Let's just do that. Let's make sure I was right. 101, I better be, minus 17. Oh, good. I thought so. And then let's do that 84 divided by 3.5. And that's my n is equal to 24. So basically what we're saying here is that to the 24th term of this sequence has a value of 101. Just to make the video a tiny bit shorter, we're not going to do that next one. But in summary, with arithmetic sequences, an arithmetic sequence is a sequence with a common difference. And we prove a sequence is arithmetic by showing that the d is equal to well, let me write it this way. That a sub n plus 1 minus a sub n is equal to d. If I take some term and then, or I could say a sub n minus 1. If I take a term and subtract the term that came right before it away, I'm going to get d. This is a little more of what I've used in honors and AP. So I'm not sure if I'm going to ask you those questions, but it's good for you. Okay, the general form, recursive. Tell me where to start. A sub 1 equals whatever a sub 1 is equal to. And then a sub n is equal to a sub n minus 1 plus your common difference. And then in the explicit formula, the version that I really like is a sub n equals a sub k plus n minus k times d. All right, that was arithmetic. And come back for the next video, and we're going to do something similar with what we call a geometric sequence.